So this is about a game that was developed with the virtual performance assessment project at Harvard Graduate School of Education. It's headed by Jody Clark-Madura under the direction of Chris Deedy. It has funding from IES. The game development, this is a little picture of what the game user sees. It was intended as a summative assessment of middle school science, and it uses applied evidence-centered design as it was designed under that as an assessment in addition to being a game. The thing is the student's supposed to find out what caused the six-legged frog mutation. So what's going on? Why is there frog showing up with 6 legs? This is the environment the student navigates through. They run around and they collect water and tadpoles and frogs, and they figure out what's going on. And as they go along, they're taking notes and they're retaining evidence in their backpack. At the end, they make a claim. They have to say it's going to be pesticides, pollution, genetic mutation, virus, or aliens. They have to make a choice based on the evidence that they've gotten so far. So the game starts, you choose an avatar, you go and talk to the scientist, who looks actually a lot like Chris Deedy, and then you observe and record you gather evidence, and you're taking notes, and you save your evidence in a backpack. You go to these kiosks that are buried in the trees to get, this is like going to the internet. So you go to the internet and find out about frogs and water and whatnot. You go to the lab and run tests. So you pick up some water, you see, oh, this water smells funny, you take it to the lab and run some tests on it, and at the end of the game, you make a claim for one of the causes of the six-legged frog, and you retain the evidence, and then you have to justify your evidence. So the problem with this is there's a ton of data. The kids run around, they do lots of stuff, and it's not like a test question where you get a right or a wrong answer so you know whether they know it. All you know is that they engage in these actions. There are over 125 actions and 8 survey questions at the end. So there are a lot of actions, and there's no real connection to correctness. So everything is known. There's no hidden questions. You know what you have to do at the beginning of the game. And if you're a savvy game creator, try everything. This is the model that the game developers use. It's this really complicated model. Don't try to understand it, because actually it was developed. It took a lot of time and a lot of effort to use the evidence-centered design, but the game behavior was not, in fact, a good predictor of the consequences. So there was only one right answer. If you collected the data, analyzed it, and really looked at it thoroughly, you'd come out with the right answer. People did that, and they came out with the wrong answer. This was teacher feedback that we tried to extract. Don't try to understand it. It's so complicated that it couldn't tell you enough. So we realized we had to characterize the data in the game in a different way, that there wasn't any way you were going to be able to get good information from it. So we took everything, all of those different actions, and we said, okay, they are either a claim for or against a certain claim. So we simplified it vastly, which makes you lose some information, but it also gets you to gain insight. So when we did it that way, you could see much clearer results. The students who did it correctly spent a lot more time at the kiosks, they did a lot more external research, and they retained and supported their evidence a lot better. So just recharacterizing the data in that way made it a lot clearer. One of the things that made it, the unsuccessful students, you could see why they were unsuccessful, which is clear directions for teachers. There was no evidence in the game to support the alien claim, but a lot of people chose it anyway. And if you've been a classroom teacher, you know who those people are. So this is the Bayesian analysis, which we are doing now, is basically saying, if you did this and this, you should know this, so the probability is you would make the correct claim. So we're going through that now and taking the model fit to different analysis. So basically we said, almost all the students collected the evidence they should have, and yet they made logical errors at the end. So this is a much clearer way to portray the data. So when you've got like a flood of data and don't know what to do with it, you have to try all these different schemes. This was a much clearer way. It gives a lot better information for teachers, even though there's less detail. So we lost a lot of detail, but we gained a lot of insight by recharacterizing the data